Okay, so if you look at this table, guys, this will get you the NM cable. And like I said, until I was talking to the engineers at PKV, I really had minimum regards for this cable, minimum regards. So I started thinking a little bit highly of it. You know, some industries are using it more, which is typically dwelling in residential and apartments and hotels if they're wood. So the key word for this wiring method, guys, if you have a wood framing, and they call it lumberyard. Have you ever driven around and you saw the framing and it looks like literally lumberyard? It's just all 2x4 framing, all and whatever they use for the joist. As long as you have the 2x4 and the joist, the wood joist, this guy can get you there. When you go riser, typically 5 foot, 5 stories. After 5 stories, they wouldn't allow you to build wood anyway. So you start going to a different wire methods. They wouldn't allow. It's not allowed to go higher than 5 feet wood only. It becomes. You can use wood, but it's treated wood. They use these big columns, wood columns that can go higher, but these are not lumberyard. These are completely different treated wood, big columns of wood and what's not. Okay, so just so you can respect that one, I want to just go over the regulation for this guy, guys. Now, can you use it for medium voltage? Look at this, the first requirement. Can you use this guy for medium voltage? Higher than 600 volt. Can you guys see that? Can you use it for higher than 600 volt? No. Very clear is limited. Let me synchronize myself so I can go on here. Okay, there you go. There you go. There you go. There you go. Okay, so very clear, guys. This is only limited to 600 volt. So can you use it for 480? Yeah, it's limited to 600 volt. Can you use it for your high voltage 13.8 and 12.47? No. Can you use an MC cable for 13.8? Yes. You can see the difference between MC cable and NM cable. That's why a lot of engineers love the MC cable. That cable, you can get it in control cable, 24 volt, 600 volt, or 15,000 volt rating. This guy limited to what? 600 volt. Okay, so that's an advantage. Now remember the B, this is the most common one. This is the guys I'm looking at that we use indoor and dry location, always. This guy is for the signal, that's for the signal. And this guy, the one that have the C, is moisture resistant. They use it in a damp location. So this is in dry location. This one, this is the B. The one that has the C is used in damp location. So, am I making sense? And this is S is for signal. So signal, damp location, dry. Am I making sense with these? Okay, so look at the use then. Maybe installed, exposed, or concealed in damp or moist location. Look at that. Can you install this one in damp or moist location? Look at this, guys. No. This is yes. This is no. Can you guys see the difference between these two? Damp or moist location. You can't use this one. That's it. They have another one that looks grayish. This is for the firing. They have moisture resistant fire retardant. All of them have the same thing. Has fungus resistance and corrosion resistant outer coverage. This is also superior. These two, can you see that these two values are only for that guy, which is the special one that we typically use it for not wet, damp location or moisture location. A special grayish one. Maybe used for wiring on 1, 2 family dwelling or multi-family dwelling. Can you use any one of them? All of them can be used. Typically, that guy risers up to 5 story. No problem, bring it on. Maybe embedded in masonry, concrete, plaster, and what's not. Can you put them in concrete? Look at any one of them. No. Forget about it. You have concrete, your conduit of choice becomes PVC or ENT, conduit of choice. So we're concrete and masonry work. Maybe installed or fished in a hollow voids or masonry blocks or tiles, walls which were not exposed to moisture. So, for example, the outside walls, these will be exposed to moisture. You can't use it. The inside walls right here, you can use it. So all of them can be used in that one. Maybe installed or fished in hollow voids or masonry blocks while not exposed to excessive moisture. If you have the word that they use, excessive moisture, the only one stand up when it comes to excessive moisture is one. The one that has a C in it, that gray guy. Looks like, where did he go? A lot of moisture. How do you define the word excessive? Yeah. You're, moisture, moisture typically, if you have voids, like here outside wall, that'll be moisture, so you can't use it there. Excessive moisture, I can think of barns and a good example where excessive moisture you can use. Um, Basements, no. Basement, you can use that one. Barns, what? Park, the underground, no, that's can be used underground. That's wet. Anything underground, remember, wet. You know, a parking ramp. Um, but this would be depending on the parking ramp. This would not be approved wired method though. Yeah, yeah. The UF is for when you have a UF, guys, is underground feeder. This is just above ground feeder for excess moisture. I know. It's just in outside walls or masonry. Look at that. If you put it in an outside wall or masonry block, look at the one that stands all the time. The one that has a C. Outside walls. Inside walls, no problem. Can you see? I'm trying to pinpoint that this is a higher grade one for excessive moisture and dam location. Inside walls, it doesn't matter. They're dry, so all of them can be fed. And they be used as service entrance. Can you use any of them as service entrance? No, 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 none of them. So these are must be protected against physical damage. Should you protect it from Chad being mad at his kids and kicking a chair at them or something? Yes. So, like you said, guys, when up to 8 feet, 8 inches, you have to put it. If you're coming around on the floor, you have to protect it up to 8 inches with a PVC conduit, put in a conduit. Okay, so these are must be protected and maybe run in hollow cases of masonry and blah blah blah. With the 116, yes, you can run them concrete or protected by a steel or plastic, then covered with plaster. Yes, yes. So this is yes. And why not? All right, because of masonry. So you can put them in masonry, guys, and cover it 116. But can you see this one stand out as a damp and excessive moisture cable? But this one, 90% of your wiring is going to be with this one. That guy will be only for probably 10% of your wiring. And again, before really PKV, I used to think minimum regards for these cables. And they were just telling me, I was talking to their engineer yesterday about their wiring methods. They said, Chad, people are making a lot of money by using the contractors by switching from this into this. They can make money and make the project much cheaper. Because the whole idea, guys, this guy is good for fire and protection. But if your building is a lumberyard, think about it. Your building is a lumberyard. I mean, what are you gonna do? I mean, if your building is a concrete building, you don't want to put this one because that will be weakest link. If your building is a lumberyard, it really anything can basically set on fire. So having a wire, this is well listed and protected to not initiate a fire if it's wired properly. Now this will give you extra protection, but if it's lumberyard, it doesn't really add a whole lot. So that's kind of the argument. And I came from this school, so I'm trying to think twice about using these, except for dwellings. So anyway, think of these guys apartments, not just multi-family dwellings, apartments, single family, two family, hotels and motels, or any building that's a lumberyard building, made out of studs, cut, everything is wood, basically. Not treated big column wood, just wood, 2x4. Okay, cool. So that will change the way you think of these. Okay, my friends, so that's what I want to pinpoint these, because the most important thing, Patrick, especially for you working for electrical contractor, wiring methods guys can make you can make probably on a project, good project. They're talking about 350, they have a hotel in 356 apartments, but of course you can't do them with this then, now you're moving to that wire. But if you have if you have up to 5-story building, each story say have I don't know, 4 apartments, and you do your math, you could save probably 50 grand just by the wiring methods they use. Isn't that amazing? This versus this. So that's why the NEC code book, guys, have many wiring methods. You try to save the public some money and the kind of balance between safety and good engineering. A lot of people hate this one though. Engineers, contractors, love it. Okay, so this is the first one I'm gonna highlight, guys. Then I would like you, please, politely, to go to the other wiring methods, which is page 126, please. Page 126. Page 126, 412. Okay. I'm going to talk about these for a second, and I thought probably this is one of the most important, I use wiring methods a lot, guys. Now, we know this guy, right? We thought this is apartment building, 5-story buildings, wood, lumber yard, right? Now, throw this aside, and let's go talk about the other wiring methods. Now, what happened if you're building, when would you switch to this? Can you immediately switch to this? Number one, if you're building a steel building, switch to this. Number two, concrete building, switch to this. Block building, switch to this. More than 5-story building, switch to this. What else? I mean, they call them type, these are type 1, 2, and 3, guys, buildings. Type 1, 2, and 3 buildings, they're concrete and block and masonry and what's not. Okay, now, we're switching to 2 types. And here's the 2 types. What does it look like? Oh, it's better there than here. These are the 2 types that we have, guys. This type, and where's the other? Where's the other guy? There you go. These are the 2 types. You're looking at, anybody can tell me which one is MC and which one is AC? MC, which one is better? MC, why? You see the difference between the 2 grounds? I don't know if you guys can see from there. Can you see one of them is aluminum, uninsulated, the other one is copper, insulated? So that's the difference. One insulated, the other uninsulated. This is one step above this wiring method. So if you want to go in an apartment, can you use this in an apartment building? Yeah. Yes. Remember, this is the worst of the worst. That's a lot of limitation there. After you get away from that, then can you use this in a steel studs? Yes. Wood, yes. Concrete, yes. I mean, concrete buildings. And the same thing. What's the difference between them? One of them has a better grounding system, which is the insulated. Okay, here's a comparing between all of it. Now, the articles that talks about all of them, guys. You see, here's the articles that talk about them and defines them as MC metal-clad cable and type AC armored cable, they call it. It talks about their definition. It's a cable's fabricated assembly of insulated conductor in a flexible interlocked metal armor. So they're basically describing what this is in both of them. I can't emphasize this as we move through, because I assume a lot of you have never walked through a wiring article, right? Other than you never have walked through any of these, and you see the article that talk about wiring. Can I get you guys to understand, when they have the article 320, the first .1 is always what? Always definition. So we have close to like 60 wiring methods. Every time you have a wiring method, start with an article, .1 is always defining what the heck is this. Does that make sense? So every time. So can I get you guys to understand this point 1 is what? Definition. Define what this is all about. Okay, so that's the definition. Number of conductors. Look at this guy. Have 2 up to 4 current carrying conductors with a ground. Any number of characters, can you see on the superiority? I'll remind you, this is more superior than this guy. So any number of current carrying conductors. So can I get this guy MC cable and 6 current carrying conductors in a cable? Yes. That guy is limited to 2 or 4. So you can see if you're doing industrial and commercial and you need 6 circuits or 4 circuits in a cable, MC cable. You see the limitation of the use of that one. Conductor size. This is my favorite. It comes from 18 all the way to 200 to 2000 kcm. This comes from 14 all the way to number 1. You guys see the limitation. Can you guys see how this guy is more superior? If you need 500 kcm, would you find it in an MC, an AC cable? Do you see where most of engineers specify MC cable? You know, you go higher than 1. This is, guys, this is like Romex. Romex stops at number 1. This guy also stops at number 1. You can't get it higher than that. So this is one step. This is just one step above Romex. Okay. Can I get you the superiority here? How superior that does in copper or aluminum? Both of them can come copper or aluminum. Can you guys see it? Copper or aluminum. Um, okay. Color coding. We have here's a color coding for 2 conductors and 3 conductors, guys. I want to go all the way to 4 conductors. Here's my 4 conductor color coding. Black, white, red, and blue. And this guy's 4 color coding is the same thing, black, white, 1 red and 1 blue, but you can get them in more colors too. There are, in addition to an equipment ground conductor, a bonding conductor. So the color coding is very similar for both of them, guys. They use, if you look at them, they use the black, red. You have your red, black, and white and blue for one system. MC cable also can give you orange, yellow, and brown and gray. Anybody remember what these colors go with? 480, 277. So these are the color coding for the, in addition, of course, to the insulated or non-insulated equipment ground conductor. Grounding and bonding. So let's look at how do they do grounding and bonding for both of them, if you can see, and putting them side by side, guys. So grounding and bonding. For grounding and bonding, this guy have the AC have an insulated grounding conductor, a separate green insulated grounding conductor. Why is it getting ugly here? Is it not ugly too much? Okay, no, it's not ugly. Separate. Can I highlight separate green insulated equipment grounding conductor? That guy AC has a bonding wire or strip. They're talking about this guy here. So they're describing the difference between one insulated green, one bonding wire, they call it. And what you do, guys, typically you cut this one and you put the right fitting on it. You don't even supposed to bend it this way. You cut it and you put a bonding fitting. This guy, you just chop it, you put the right fitting on it. You don't tie it to anything. And the shield of the cable, as well as that wire and the connector, act as your equipment grounding conductor. For this guy, the main equipment ground conductor will be going through the insulated, and this also will give you some equipment ground conductor, a redundant equipment ground conductor. Am I making sense? So this guy, you don't chub it; it goes directly into the box. So that's Now here's another superiority, guys. Right in here. Oops. How does it look like? Okay. In terms of insulation, the insulation that they come is this comes with THHN 90-degree, guys. And also, this is also 90-degree MC cable. In terms of 75, also Steve HW 75. The ampacity of these conductors, guys, typically the ampacity of this conductor is based on 75-degree column. Both of them are based on 75-degree column, depending on the lugs. Now, you're going to tell me, Chad, here's a conductor. If I don't know, guys, this is number 14. If I don't know which column to go to, number 14, AC or MC cable, have no idea where the lugs is. Where's your default? The which column? Is it 60-degree column, 75 or 90? No derating. 60. 60 if you're not derating. If you're derating, can you just see if you're derating, then you can go to 90-degree? Okay. Now, both of them, guys, you have a cable. If the lugs are rated for 75, where do you default? The lugs are rated on both ends of both cables 75. Where do you go? 75. So they're unlike, but for this guy, regardless of the lugs, where must you go at all times? 60, the worst of the worst. So. Okay, so that's basically a few. So the installation can come as 90 or 75, but when you go, you guys go to, depending upon, you can go to 70 or 95, depending upon the situation. Okay, the next slide, guys, compare the galvanized steel or aluminum. They can come in galvanized steel, aluminum. Same thing, galvanized steel, aluminum, or copper. You can get them in copper too here. There's different sizes, interlock, different type. Can you guys see the armor has different type? There's interlock, and there is different type that they make them. Covering over armor, no covering. You can, what they do with this cable, believe it or not, they can put a PVC cover over it. Why would you do that? So this guy have no coverage, but this guy can have a PVC coverage. Suitable for what? Look at the word. Wet location. For different burial. Look at this. Burial and correctly concrete encasement. Now, can I bury this one or bury it in concrete? No. Can I buy an MC cable that has a PVC cover that can bury in concrete or in concrete or on the dirt? Yes. But typically, guys, we don't do that one. If you go, most of the application, if you go underground, PVC. But if you want to go underground with feeder, you don't want to use PVC and conduit. MC cable with PVC cover, rated for wet location. It will be expensive. This will be an expensive solution for PVC conduit and wires. Why wouldn't you use it? Expensive solution. Okay, so that's location. Let's look at the location. So we got that. Where can you use this cable? This is another very important feature, guys, of that wiring method. Where can you use this cable? Look at that. Okay for dry, no problem. Okay for damp or wet location. Not okay for direct burial. Not okay for direct burial. Wet location, no problem, but direct, there is a difference between wet location and direct burial. Anybody can know what's the difference between wet location and direct burial? You put it outside wet location, it's exposed to what? The elements. Heat, rain, snow, sleets, right? When you bury it in the ground, it's exposed to what? Water. What else? Frost. But there's something more important than that. Corrosion and agents. You know, these agents, the chemicals in the ground can act on it, guys, and kill it. There are chemicals in the ground that can act on the steel or the aluminum and destroy it. So when you put a cable in the ground, in addition to be rated for wet location, they also have to be rated to handle the agents in the ground, the chemicals that can destroy the insulation. Am I making sense? So you can have a cable rated for wet location, but not for direct burial. So you have to have wet location is not always. Anything underground has to be for wet location, but direct burial, it depends. It depends. This guy, is it okay for listed for wet location? If it's listed, how about direct burial? Bring it on. If it's listed, be installed in a raceway, why would you do that until it's physical protection? It's okay. So for the most part, guys, okay for damp or I don't know about wet location here. Question mark. I don't know if they make wet locations in that one, but for the most part, AC cable. This guy is only dry location for the most part. Bending radius. Do you guys know, they keep talking about all the right methods, and I'm sure you guys went through it. When you're bending radius, how far can you bend when you bend that cable without screwing it up and busting it, right? What happens if you keep bending on it? What's going to happen to that? Done. That's going to be you guys when you go in the field. You see, you do inspection, and the extrusion bend is so tight. Well, you violated the bending radius, gentlemen. So look how they do the bending radius. 5 times, look at all of them. Guys, this is for all cables. Can I get you to understand this is for all cables? 5 times the diameter of the cable. The diameter of the cable. So, Gary, what do you think the diameter of this cable is? Half an inch? From here to here? Smaller than that? 3/8? Okay, 3/8. So you take the 3/8, multiply it by 5. Can somebody give me the math, please? How much? 1 inch and 7/8. 7.875. Or 1.875. Or how about the 7/8? 1/7/8. And then when you bend the radius, you put the so this is the bending radius. So here's your radius, guys. You start right here and make sure you bend it. The minimum radius is not. You can have larger radius, but the minimum bending radius from here is at least 1 7/8. If you bend it sharper, the more you bend it sharper, the smaller the radius here. The bigger you bend it, the bigger the radius. But remember, this is min. Bigger radius means like you keep doing the radius more until it becomes almost straight. And I know you guys you assume none of you have ever seen this. I'm reviewing this because it's typical for all cables, not just for this cable, all cables, 5 times. So 5 times for this one, smooth. This guy, the AC cable, actually 10. The Annam cable is 10 times the diameter and then also 12 times the diameter for sizes. They're for different sizes, 3/4 inch and not over. So they have, because this guys comes in a multiple. Let me go all the way up to here. Because this is 5, which is typical for all cables, but MC cable guys come in different sizes. So they give you different multipliers. Here's 10 for certain range, 12 for other ranges, and 15 as well as 7 diameter, 7 times the diameter of the cable. If it's corrugated or interlocked. So anyway, there's 2 different types for these one with different multipliers for them. Super neutral. What is the super neutral? Super neutral. Super neutral? Not super. Super. Super neutral. Super neutral. Not available super neutral. Available with super neutral where required. Super neutral, guys, when look at this. How many neutrals do I have with these? 1. What happens if you need 1 with every phase? Actually, we have 1 that has 3 phases. Yes. Yes. 3 neutrals. Here's look at this. Well, this is an empty one. A larger size, either larger, yeah. Super neutral, 2 ways you can do them. Either we have the neutral, so this is the neutral. It's actually super, you're right. Super is when they oversize it. Super neutral when you oversize, so this is number 14 and this will be number 10. Okay? And multi-neutral, you solve the harmonic guys in 2 ways. You solve the harmonics in 2 ways. Either by, if this is number 14, you can make this is number 10. Or, if this is number 14, I have 2 of them, what do? I have 2 whites with them. But you're right, I think super neutral is when they oversize it, not when they multiply it. But I don't think I don't think even it comes with a neutral in every phase. So the neutral will be larger than the other conductors. Okay, so you can see where the MC cable is superior. Last thing, guys, is support. Look at the support. When you support it, my support is every 3.5 feet. Can you see that? Supporting this cable every 3.5 feet. Support for this guy, 12 inches from every box every 3.5 feet. So here's my box, 12 inches, and in between the support, 4.5 feet. Okay? That's my support. They can run unsupported if they're fished and then what's not. Fixture width, can you see that number 6 here, support for ceiling accessible length, that's your fixture width. Can you guys highlight that one? So can I have 6 feet of it not supported tied to a fixture? Bring it on. Okay, let's look at the support for this guy. Not more than, what's the support for this guy? 6 feet, 12 inches. So 12 inches and in between 6 feet. So anyway, so you can see where the support is different even. Not more than 12 inches for boxes, blah, 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 or number 10 or smaller. Support not needed where cables is fished through the, if you fish them, you can also use it. Can you guys see you can use it also as a fixture web? Fixture web. Always, all these cables, guys, they can be used as a fixture web with 6 inches tied to a fixture. Any comments, guys, about comparing these 2 cables? Comments, questions? Go to the next one, guys. So that's okay. Here's the last thing about this cable, and again, I'm emphasizing it, guys, because it's so important why our methods go through these. So voltages. Look at the superiority. Now another thing. Can you guys see the indication of voltage? MC cable can voltages or less. Some MC cable have a voltage rating of 600 volt, but I know for a fact they can get 15 kV MC cable. So you can have higher rating for MC cable. So you have 2,000, but you can even get it higher than that. 15 kVA or kV. Yeah, kV MC cable. So these you can get them in higher voltages. Thermal insulation, we talked about the 90, and this is also, both of them are 90. Connectors, different type of connectors that comes with them, with the UL listing and what's not. Any comments, any questions? Summarize. Summarize. This one, guys, will be the next step above Romex, if you can get away with it. This one will be the third step above Romex, which is the best, the MC cable. So for the most part, AC cable can, guys, get you all in a lot of places. Almost can replace MC cable. Any comments, guys? Any questions? Comments, questions about these two wiring methods? Or three wiring methods with cables. There's one more table, guys, that tells you other uses. I'm going to go right here. Comparing the two together. How about services and feeders? Let's see about services and feeders. And all this is in an cyclical. Can I use it as a branch circuit and a feeder? Yes, yes. Can I use it as a service? Oops. Now that you drop the MC cable from the... Do you guys see another advantage of the MC cable over the AC cable? Can I use it as a service? No. How about Romex? Can you use this one as service? No. But you can see it starts filtering. Dry location. We talked about dry location. Bring it on. Wet location. Typically, this is no wet location here. Wet location only. You can put in wet location if it has the cover on it. They have, which they do. They make them with a cover. Can you put any one of them where Chad Kearney can drive his Suzuki? I used to have a Suzuki. I don't drive my van anymore. It's too expensive. I used to have an old Suzuki, and I used to tell the students when they teach, can I, because it was rusty and I don't care. Can I drive my Suzuki into? Can this protect me from driving my Suzuki into it? It hope not. So what do you need to do if it's physical protection? You put it in a rigid. You put this cable there, directly into a rigid. This schedule 8 to protect it. Very clear. In masonry walls, we talk in raceways. Can I put them in raceways? In a raceway. This one you can't put in a raceway. This one you can. That's an advantage. Direct buried or in concrete. We talked about this one, guys. This is off. This is yes for MC cable. And putting it in attics and what's not, and roofs. Both of them can be put in an attic and what's not. This is kind of describing how you put them in the attic 6 feet away from the opening of the attic and what's not. So both of them can be used. Any comments before we use these very, very important two wiring methods? And this one. Okay. So I wanted to spend some good time, guys, just discussing these because they're important. Now, I'm going to move into the conduits. Let's move into the conduits. Now, remember, guys, here's the rule. What's the rule? When you're wiring, rule of thumb. What's the rule? Ouch. Okay. Can I get you to summarize the rule in wiring methods? Okay. Can you repeat after me or tell me if you are going underground, what's your conduit wiring of choice? Schedule 80. 80 is stronger and more rigid. Or 40 would work, but typically underground PVC schedule 80. Now you're going above ground in an area where Chad Kearney can drive his Suzuki right into it. What's your conduit of choice? Rigid. Steel, typically steel rigid, where you can drive right into it. Okay. Or schedule 80, or schedule 80. PVC schedule 80 will do you. Now, if you're wiring outside, you're not underground, you're just outside, you're on a roof or on the walls. What's your conduit of choice for outside above ground? PVC or EMT? EMT will cut it with the right fittings. This is also the problem with PVC, guys. The reason why, anybody can tell me why, you probably know, why would we put a lot of PVCs above ground? Thank you. What happened when this heats? Not melts, it sags. It sags. It looks crabby. So you can do it, but what they do, the code requires you to have an expansion fitting here, so it allows it to expand and contract. But if you have longer runs, it looks really sags. So you have to support. So that's why if you're above ground like here, they typically will use EMT conduit with a compression fittings. The compression fittings watertight. Okay. Now on the roof, This one also will get you the EMP with the compression fitting. So that's why EMP also in a wet location above ground will work. Now we get inside the building. Home runs almost always inside the building. Home runs almost always. EMP, home runs. From now up to the box, from the box to the devices, what do you use? Now drop this one in the commercial, right? We're using conduits. Then from the box, you can either use this cable or that cable, MC or AC cable. MC cable. So conduit engineered project, EMP home runs, MC, is this MC? Yep, MC cable, guys, between the boxes and the devices. So if you go in this wall, you take your home run into a box. Typically from the box, you take an MC cable, drop through the wall, pick up this, drop through the wall, pick up the other one. Can you also drop with these? Yes, you can. But the cheapest installation, home run for these are in between. That's it. So let me, yes. I think it's It's just fatter. This is schedule for it. And what is this schedule? This is schedule for it. There are different sizes. There's just like a thicker wall. Yeah. I think that's something that you guys see. Thicker. Richard, you can very clearly see the difference between the rigid and the heavy. Oh, that's just rigid and very clear. Okay. All right, gentlemen. So let's talk a little bit, guys, about. So if you don't mind, please, I'm going to talk a little bit about the different conduits. A few things about different conduits. I think it's really interesting. Again, these are all coming from different articles, guys. Okay, and since you guys have never seen wiring methods, I thought. Okay. Okay, gentlemen, bins. Can I get you guys to understand first that this is called IMC, rigid, and PVC, and this guy is EMT. These are the most common conduit wiring methods, not cables, conduit wiring methods you're going to encounter. They call them non-flexible conduits. Okay, bending them. When you bend this, how many bends you can do with this? How many 90s you can do with these? 4 90s. 4 times 90 is what? 360 degrees. That's all of them. Can you guys hear? 1, 2, 3, 4. You cannot bend. You guys, do you know how bending conduit works? Bend it 90 or 75. You keep adding the bends. So if you have a conduit, you go this way, this way, this way. So here's 90, 90, 90, and so I started right here. So I can go one more 90 here. Does that work? 1, 2, 3, 4. 4 90s. So I'm going back to where I started. But now what happens if you need the 5 90s or another bend? It doesn't have to be 90, it could be 80. Thank you. You put a box. So gentlemen, what do? You put a box here and you start over. You put a box. Anybody knows why? Remember, you're pulling wires out of these suckers. How do you pull a wire through 490s? You know the electrician who's going to be pulling it if you design something like even 490s, they will be cursing you. Especially if you're putting 500 KCM, 4 of them. Talk about cursing. So typically that's the max, guys. You wouldn't go even there. Okay, so that's the bend. We talked about this is your bends. Bending radius. They have different. Chapter 2. I would like you guys please to go to chapter 2. Could you please go to chapter 2 table, chapter 9 table 2, chapter 9 table 2. if you go to chapter 9, table 2, let me see. Chapter 9, table 2, it will give you the bending radius. Chapter 9, table 2, give you the bending radius. Thank you. Chapter 9, table 2, right here.
Does every state follow this, or do the states also have like their own like?
Almost, they adjust it. Almost all the states follow it in one way, shape, or order, and adjusting it with some adjustment.
Like some
Okay, 756, guys, gentlemen. Okay, bending radius. When you bend the conduit, here's my conduit. What's the minimum radius that you can bend? R. Here's my conduit going this way. Oops, going this way. What's the minimum radius? If my conduit is 3, if the size of the conduit is 3, this is non-metallic, this is metallic. So which one would you use for metallic? The one shot, non-metallic, the second one. Okay, EMT, Brandon. What's EMT? Is it metallic or non-metallic? Metallic. I hope you do that. Okay, what's the bending radius for 3-inch EMT? Is it a 13 or a 10? I can see. 13 inches, bending radius. Now, what happened? 3-inch PVC. If it was a PVC, what would be the minimum bending radius? Is it 18? 18. Can you guys see that? So when you're a project manager, Gary, and you're going and they're bending all these, and you see a conduit that's bent so sharp that almost broke, that bending radius is not followed. When you bend, there's rules, guys. When you were doing bending in the machines that we have here, one shot, and you can decide the radius for the bends.
How you figure out, say, trick method, have the GMT, and says the radius is 4. How you measure that on the GMT?
Oh, you go by the trade size.
Yeah. How do you take the EMT that's already bent and make sure it's 4 inches?
Well, these are for segmental bends, not the right angle. When we bend conduits, there's different ways of bending conduits. There's 90, the 90 degree, and there's also segmental bends, guys. They have a machine that bends it this way. They different shots and give it this way. So the way, how can I decide? Well, you're going to go draw that, and when you draw it, there's rules, guys, and you put yourself, there's some tools that put yourself here and here, and find the center of this curve at this area and this area. What do you call this little, what do you call it? That little thing that, not the compass is the one that you, yeah. Not the compass, no, the machine,
Does it measure?
it finds the curves. Protractor. Yes. So you can draw that one and you find the center, and then of course you measure the distance from here to the LV radius. There's some calculation to be done.
What did you recommend metallic and non-metallic for?
Because anything, if you go through the code, it says the non-metallic ones, they always go other bends because you bend it by hands and you heat them.
You can use the machine on PVC.
The PVC is,
You can't use that PVC.
yeah, the one shot and the full shoe, these are machines and hands, and what's not, these are metallic. No, absolutely. But metallic on these, non-metallic on the others. Are we good? With metallic, non-metallic? Okay. All right. Bushings. Bushings, gentlemen, I'll give you a break. I think it's Friday. I'll give you a break in a second. Let's talk about bushings, will ya? Bushings. Bushings, guys, are required where number 4 or larger here. Where number 4 or larger here for these. So these are for required where a conduit enters a box filling and what's not. The first one with that, these are rigid, metallic, number 4 or larger. Typically, all of them are number 4 or larger. You're required to put bushings in all of them. Number 4 or larger bushings. required where the conduit enter the fittings or the box, number 4 or larger. So here's what happened. If you bring a conductor, number 4 larger, when you pull the conductor, because it will damage the insulation, so they have to have that plastic little fitting they put here to protect the cables. They call them bushings to protect the cables. Rounded insulated equipment must be used. Not required where the rigid terminated in a hub and what's not. So that's for the most part they're all required. If it's threaded, if the conduit's threaded like rigid, it's required on every side. So when you bring it into a threaded rigid, where's my threaded rigid? You guys feel my threaded rigid here?
Alex run out of the room laughing. Yeah.
When you have a fitting, like threaded fittings, guys, right here, and when you pull a conductor, when the conduit is threaded, like rigid and muted, what's going to happen to these conductors when they touch the place where you threaded? It's going to damage it. So what they do for threaded conduits, they always put bushings. Any conduit, regardless of the size. All other conduits only if larger, number 4 larger. Okay. So that's probably when you do the installation. Cable is permitted. Cable permitted inside. Can we put cables inside all of them, guys? Look at this. Can you put cables inside all of them? Yes, yes, yes. Can you put cables? Cables, not conduits, cables like these. Can you put a cable inside them? Typically, why we do this? Who in his right mind would do something like this? Physical protection. Severe physical protection, yes. Okay, cinder fill. Can you put them in a cinder fill? Yes, almost all of them, yes. We're subject to permanent moisture, the PVC, blah, 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 listed 2 inches. So for the most part, yes, with some restrictions. But obviously, if it's, so that's, we're subject to permanent moisture, blah, 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 sides moisture, 2 inches, list. So I'm going to move into that one. Concealed in walls. Can you conceal them? Bring it on. Concealed above, can you put them above grade? Bring it on. All of them. Concealed on grade. Bury them basically. Yes. Rigid, yes for galvanized. Rigid PVC, yes for galvanized. Look at the EMT. Can you even bury the EMT, guys? Yes. But it's not your conduit of choice for burial though. Concrete below grade. Below grade, your conduit of choice, like we said, become as PVC is your conduit of choice below grade. Conduit fill. How many conductors you can fill? All of them. We'll talk about conduits, conductor, because when you fill the conductors, you have to all of them go to this table. Can you see that? How many conductors can fill? Chapter 1, table 9. I'll show you later on how to find that one. Conductors. Okay, so we got the conductors fill. Corrosion condition. If it's corroded, without getting into all these details, all of them guys can be installed with some type of protection. But if you have a corrosion, any one of them can be treated to be in corrosion. But we're designers, guys, and engineers. If you have any corrosion, your conduit of choice would be what? PVC. Even though the others can fit with some treated and what not treated, but your conduit of choice is there. Damp and dry location, all of them. Expansion fitting. Remember we said, why don't we use this above ground? Because it expands a lot. So can you guys see, everybody knows what an expansion fitting, they have a little fitting here that allows the conduit guys to expand. Allow the conduits to expand and contract, especially in Minnesota. We go from 100, almost 100 degree, 95 degree, into 20 below. So required, look where it's required for a PVC. So remember, you have it. Exposed, can we use them exposed? Bring it on. All of them are conduits ready to be used exposed. Fittings. Can I use threaded fittings? Threaded. Here's the threaded fittings. Can you guys see that little thing? Fittings is threaded. Do that. Should I give you 5 minutes break? Let's do a 5 minutes break. I know I see. Okay. Can we take 5 minutes, guys? I know you're stretching. It's Friday. Let's do a 5 minutes, shall we? Thank you. Fighting. Let's continue with that one. Okay, threadless connectors. Let's talk about connectors. Again, can I get you guys to learn one thing from Chad? Do you guys see these tables? Have them close to your heart, these tables. Very important. Even though they're residential, I've never seen in my career such a table that describes such a 4-wire methods side by side, compare them to each other, as good as this table. I've never seen a table like this. I really never. So in terms of fittings, the fittings that they use, guys, they're threadless and threaded fittings. You guys are familiar with threadless. Threaded, here's a threaded fitting, so we can thread it, right? So the threaded, they're threadless and threaded. Now with rigid, we can use both threaded and threadless. Threaded, threadless. With the rigid, with the PVC guys, they don't have threaded. You slide. Have you guys done the PVC? You slide the connector, and there's some cement that you put on it, and you glue it basically. So glue one for the solvent, what they call it, cement that they use. And for the EMT, the reason why EMT is so important because they use set of screw or compression connectors. Very easy to work with. Look at this one, guys. This imagine when you do wrenching and all this good stuff. A lot of work. So for the EMT, you slide that connector with a set of screw, tighten the set of screw, and you're done. Now with rigid, this is a lot of people don't understand. With rigid and intermediate, guys, you can have two types of connectors. You can have a connector that threaded like this, or a connector that actually slide into it, and with a set of screw or compression. A lot of people don't think of rigid as it's always threaded. Doesn't have to be threaded. It's always used as threaded. The reason why you use it, because it's threaded. So you use threaded connectors with it, but you can use non-threaded. Okay? Yes, sir.
Is there a certain length they can't exceed conduit? Like, could that be a certain size? Like they can't be 30 feet?
The distance.
Yes.
The only limitation on the distance is using it as an equipment ground conductor. Hold that question until we reach it. Yep. That's the only limitation. Can you pull them 500 feet?
A solid one from here to there, or does it have to be a break so if something happens, you can get in the picture?
Can you hold this question for 1 second? So I can remind me when I talk about it. Grounding actually is right here. We're going to be talking about it right in a second, guys. Grounding. So threadless and threaded. Remember, thread and threadless. With this one, typically threaded, you can use both threadless and threaded with these two. This one is typically solvent. You plug it in, it's glue. You glue it to the PVC. This guy is always threadless, and two types. Type is set of screws. I wish we can wire you guys. You put them here, you tighten them. This is indoor. Outdoor, they call them compression ones. Compression ones, which is basically watertight. So if you're using them outside, they have to be the compression type, which is watertight. Okay. Grounding. Grounding. Is this an equipment ground conductor like the green guys? The conduit. Yes. So equipment ground conductor, it is considered an equipment ground conductor, considered equipment ground conductor, considered equipment ground conductor. How about the PVC? Required equipment ground conductor. PVC, I mean, is non-metallic. You guys remember from Poly's days, does the current go to insulating material? We're in a big trouble if that happens. We're really in big trouble, right? If that happens, how are you going to insulate the conductors? The whole, you can't do anything. Anyway, so this is an equipment ground. Do you need to pull an equipment ground conductor with these? The rigid, the intermediate, and the EMT? No. What was your question about the length? The length, guys, here's what we do with typical with length. If you have how far you can go with the conduit. So typically every 100 feet, typical, this is not a code, every 100 feet, you want to have a junction box or a pole box. Every 100 feet or so. You know, you might, if it's a straight run, you might push it for 150, 200. Now, that's rule number one. Rule number two, remember the 360 degrees? Every time you bend the conduits, here's 1, 2, 3, 4. Okay, here's my box. My first box is sitting right here. Here's 90. Here's another 90. A third 90. And I'm going to come here to the box. And a fourth 90. And then I'm going to continue. Now I have to continue. Here's another 90. And here's my machine. Can you guys see that? Here's 90, 90, 90. 490s, you have to put a J box. Every 360 degrees when you bend them. And they don't have to be 90s. They could be 70 and 80. You add them up. You know what I mean?
So there's no standard on how long the screws like that has to be.
Doesn't have to be. No, there's no standard. No.
Come in section 10.
Oh, is that what we're talking about? The sections of 10 foot?
Like how long is one solid 1 feet?
Oh, one solid is 10 feet. One stick is 10 foot.
No, he's asking just how long, like, you just sent conduit for like 5,000 feet. Like,
You just run it like one solid piece from that end of the ductwork to that end
No,
without a box.
100 feet.
it's straight.
If it's straight.
100 feet. 100 feet.
Well, by the code,
But the code you can. But
ease of
yes,
pulling.
ease of pulling and installation, typically 100 feet. Every 100 feet, guys. Yeah, every 100 feet you need a pull box. Is that what you're looking for? Okay. Every 100 feet. Now here's another restriction. If you're using it as an if you're using it just as a ground, there's also other restrictions. Like I can't remember, but EMP conduit, for example, I think after 200 feet, it becomes ineffective. If you're running it after 200 feet, it becomes ineffective as an equivalent ground conductor. So what do you need to do? You have to pull an equivalent ground conductor inside. So there's a table, I'll share with you that it's not in any secret book, where there's limitation how far you can pull a conduit and still effective equivalent ground conductor. Joints, there's listed couplings and connectors. You're looking at a couplings here, guys, right here. Use proper cement for these. Use listed couplings and connectors. Can I use the EMP connectors on rigid? No. Can I use the PVC? Listen. Can I use the PVC connector on rigid? No. So each one of them, guys, have sets of fittings and connectors. Length. What are the standard length that they come from? Anybody ask me about a conduit? Always the stick. One stick is what? 10 feet. Typically, all of them. Do they have to be listed? Can I use the water hose, garden water hose as a conduit? No. Why? It's not listed to be a conduit. So they have to be listed by me, by Chad Curdy's basement lab, or by UL. By UL. Okay, material. Look at the material that they make them from. This is really interesting as opposed to corrosion. You can have steel galvanized for the rigid, steel galvanized or aluminum for the rigid, and the intermediate. For the intermediate, steel galvanized or aluminum for the rigid. PVC, of course, is PVC 40 or 80. What's the difference between 40 and 80? 80. So you're supposed to drive my Suzuki, old Suzuki, into the 80. You think you'll handle it? Supposed to, but if you have to drive, what they do, guys, in these chemical plants and manufacturing, they don't even use 80. They always use rigid, because you can drive all these forklifts and whatever. You drive it into that rigid, the wall will cave, still standing. So, how about the EMP? You can get the EMP, guys, in typically steel, or you can get them in aluminum. What's the difference? Why would you pick an aluminum? Cheaper, lighter. Wait. Typically steel, but these are the material. Who cares about these material? Corrosion. Lighter. And conductor-wise is cheaper. Definitely. I think it's steel. I think also.
I said aluminum was more expensive.
Yeah. The conduit. With the conductor is definitely. The conduits, I'm not sure. Yeah. But that's the advantage of it, is lighting. I'm not sure of the conduit. I really don't. I'm not sure of the price. But if I have to guess, probably steel would be. You would think, yeah, the aluminum has an alloy and what's not. So we got the joints material. We got the material, guys. Rough it. When you thread it, do you guys have to smooth that threads when you cut it? Of course you do. What happens if you don't smooth it? You use your plier and you move your plier around it, right, to smooth that cutting. What happens if you don't? When you pull your conductors, what's going to happen to all this insulation? Cut it. You guys already know that. Why should we go over it now? Okay. Support. Support of the conduit body. If you have a little conduit body here, these need to support. All of them need support, basically. Conduit bodies not containing devices or other equipment. Yes. Securing. If anybody tell you about securing, how far you need to secure it from a box? Almost all of them, guys, almost all of them, when it comes to securing from a box, 3 feet. So here's the box, you go 3 feet, and you support it, 3 feet. After that, typically 10 feet. There's, it changes. Typically 10 feet. After that, supporting every 10 feet, 10 feet, 10 feet. PVC has a whole table for it. And also there's a table. There is a table, and this one has a table. Like PVC, for example, PVC 3.3. But if you have to go PVC schedule 80 that goes into 6 inches, it becomes different. So there is a table for support them. But the general rule is 310. That's the general rule for conduits. But there are supports. I want to bring you guys your attention to the size. What size industry sizes did it come? Look why rigid is superior. I want you to pay attention to this number and this number. You guys see why rigid and PVC schedule 80 are used commonly. If you need anything larger than number 4, what are your options for the most part? Rigid or PVC, larger than number 4? Look at these. These are limited to what? To number 4. Limited to number 4. Threaded. Which one are the threaded ones? These are threaded ones. These are no threads. No threads on them. So these are a few comparing. That's what I like, guys, about this table, is comparing them side by side with all the stuff that they have. Moving into the second one, let's look at the use. And I know I'm reviewing it with you because I really want you guys to know that. Because this is what, you know, from now, regardless of your friend Chad is going to continue or not with you, whoever is going to come, when you guys start pulling your industrial project, you bring in 4,000 amp service interest conductor and you want to size it. Chad said PVC underground, right? You start doing PVC without. Now we're in the building, we're pulling feeders from point A to point B. What's your default? EMT. Okay. So that's what I'm trying to, guys, get into you. Underground. Here's underground in soil. Underground in soil. Now tell me, which one is your conduit of choice? PVC. Now, can you put rigid there? Yes, it has to be treated. Steel, if it's galvanized. Steel, not for non-galvanized. Can you put steel, non-galvanized steel in the ground? You can, but you're not going to find it after maybe 5-6 years. You know, you'll find the conductor sitting there and everything is. Have anybody seen? I did a service call one time for a store, and the conductor literally, when it shorted. When we dug through, the cable was going to the sign. So I dug through and down to, especially where you come by the parking lot into the garage in Minnesota. What do we do in the winter? Salt. We put a lot of salt. That salt pushes against the steel into the ground, and the whole thing here was gone. The wires were sticking in there all the way underground and shorted. No wonder. So the conduit guys disappeared. So anyway, so even though you can put them, guys, yes, you can, but should it be your conduit of choice underground? Should not. The weight, this is just a few things about how much they weigh. Why do we care about the weight? When you deal with the structural engineers, Gary, the first thing they need to do in a manufacturing, they want to know, you want to mount this one to my ceiling, right? Imagine if it's 6-inch rigid. You want to mount this 6-inch rigid, 200 feet run of 6-inch rigid to my structural ceiling. Don't you think the structural engineer need to know a little bit about that? Right? Wouldn't you think so? That huge load with cables, 500 or 600 kcm, 5 of them in it. Imagine the weight. So structural engineers, if you know feeders, bigger feeders, guys, you have to, when we design, when you guys design, you're going to convey this info. If it's suspended from the structural ceiling or walls, your structural engineer should be involved. Otherwise, you bring the roof down. You know, so that's where weight becomes a big deal. Wet location, can you put all of them in wet location? You can see their wet location, not direct buried. Wet location, like outdoor in the wall right here, above ground. They're all listed for above ground. But if you're in wet location, which one above ground wet location? The cheapest above ground wet location, no physical damage. Which one your conduit of choice? Remember PVC above ground, what happened to it? It sticks. The most economical. I should say the most economical. EMT. So EMT would be your conduit of choice.
Seems like they should just use EMT for everything.
Underground, you're absolutely right. EMT,
Galvanize.
if anybody ever tell you guys, if anybody ever tell you, what's your what's the wiring method in everywhere, and you said EMT, you are right up to 90% of the time, guaranteed. If you say EMT, you're right 90% of the time. When would you be wrong? If you're going underground, you're wrong. If you're going in hazardous location where Chet is looking driving right into it, how often that would be, like right here on the close to the wall here where you park your car, Chad coming drunk that day, hit the accelerator instead of the brake. So that would be rigid. Forks in the manufacturing floor, you guys going to be touring manufacturing floor. The forklifts are running around all over, rigid. Gas stations, hazardous location, flammable gases and liquids and dust, rigid. So these are really the only place that you can use, you don't use EMT. So you're right, 90% of the time, EMT as a conduit between the EMT and the MC cable, guys. I told you that, I think, from the beginning. So in the EMT and MC cable, you covered 90% of all the wiring almost everywhere between these two. Almost. You can use this in homes, even, but you overkill. You'll be overkilling. You're right, beside homes. Homes is Rolex for the most part. Okay, any question, guys, about these before I move into the flexible? I hope you guys understand why I'm spending some time on it. This is really the bread and the butter of what we do as engineers. Wiring methods, understanding them, comparing them with each other. Okay, now we did cables, we did conduits. What else next we need to do? Between cables and conduits, guys, you're 99% ready for any wiring methods. What's left? What's left, actually, almost 100% ready. What's left is these. Flexible metallic conduit. Now, what the heck is these and why do we use them? Where's the other one? Yeah, you tie in vibration, tied to the machine. Vibration and tied to the machine. That's the only time these become handy. Other than that, if you want to wire Dunwoody with these, you'll be fooled. Everybody will make fun of you. You know? Can you? Yes. Should you? No. Would you be fooled? Yes. Okay, so let's go compare between these guys. That's in table number, flexible metallic conduit, please. This is start at page 141, table 416. Let's just look at these. And very quick, again, this is only time to equipment, remember, even though it's wiring methods and what's not, time to equipment. Now guess how many bends you can put on these, right? Same thing, bending them. When you bend them, all the conduits, guys, you can't bend them more than 360 degrees. Bending radius. Bending radius, they take you all the way to table 2. Table 2, flexible. We typically use the non-shot, whatever, the second column. So that's where you bending radius. Bushings. Everybody knows what a bushing is. The conductor starting out, if they touch the conduit, they will be damaged by this. So what they do is they have a little bushing, they slide it in here to protect the conductor. When do you need that little bushing, plastic bushing, they push it in? When do you need it? Almost all conduits, you guys need it if the conductor is 4 or larger, 4 or larger, 4 or larger. All conduits. Do you need them? The only time you need them, the only time you guys need them for smaller than number 4, anybody can guess? If you have a threaded conduit, and they have the threaded conduit and not threaded connector. Threaded conduit stick inside the box, and they have a little connector here and a little connector inside. So the thread itself is completely exposed. The threads that you did expose in the box. They do it sometimes when they wire. That's the only time when you need bushing for every size wire. Okay, cable permitted. Can you put cables on them? Yes, if permitted by the specific cable. Yes, yes, yes. All of them. Can I put here? Can I put this? I don't know why. I can't think of a way because they don't protect you from physical damage. I don't know why. I guess the only way I can see maybe through this. It's not, yeah. So you can use it to protect this one from not severe physical damage, just physical damage, right? Direct burial if they're rated for that. Direct burial if they're rated. Oh, yeah, they have to be completed. Cable permitted, concealed in walls. Can you put them concealed in walls? Yes, that's why they have them. Concrete above ground. Can you put them above ground? Oh, by the way, flexible metallic conduit. Oh, I should have mentioned. Where are they? This is flexible metallic conduit. This is flexible, this is liquid tight. Can you see the word? Oops, liquid tight. So they have a jacket on it. Liquid tight and still metallic though. This is non-metallic. So one of them, it looks like, I don't have a cable, but it looks like this with a jacket on it. You guys have seen it for air, your air conditioning is with it, a jacket on it. That's liquid tight flexible metallic conduit. The other one is everything is non-metallic. The whole system. I wish I have a copy of that. The whole system is non-metallic. You guys have a picture in the book. Okay. So we put them the non-metallic. Remember that anything non-metallic, yes, yes. When you bury things, direct burial, non-metallic burial, yes, if marked with direct burial. Concrete, so concrete above grade, concrete on the grade level. In concrete, you can see the non-metallic. I always tell the people, if you think putting things in concrete, buried in concrete, if you don't know which conduit, always think non-metallic. You don't want to bury metallic conduits for the most part. You're always right. Conduit fill. How do you fill them? Table 1, the same thing, guys. Table 1, chapter 9. All of the conduit fill will be going to this. Table 1, chapter 9. How many conductors can fit in each one of these? Oops. No, we don't want that one. Okay, so that's this one. Let's go to the next one, guys. Conductors, when to install. Can you have to install the complete raceway. All of them have to be complete raceways when you install the conductors in them. If you're using them as a raceway. Corrosion condition. Can you put them in corrosion condition? All of them are yes, but typically here's why I highlight the yes. Corrosion condition, these guys have to be treated, but for the most part, non-metallic corrosion condition is yes. Dry and in a dry and damp, look at that. In dry and damp location, bring it on. Now exposed, bring it on for all of them. Fittings must be listed. All the fittings have to be listed. Grounding. Look at the grounding though. For grounding, are they used? Can we use them for grounding? The answer should be no. But there are limitations though on that you can use 6 foot. Here's a limitation where they can be used. Typically 6 foot, guys. Obviously, this cannot be used as a grounding, right? It's non-metallic. This guy have a limitation of 6 feet. What does it say? For fixture whips, 6 feet. And there's also a couple of limitations on the overcome protection device ahead of it. So I don't want to go through the whole thing, but the limitation, guys, is you don't need an equipment ground conductor for it when you tie it to a fixture like this. When you tie it to a machine, an air handling unit that vibrates, do you need to put an equipment ground conductor in it? You would hope so, right? Am I graphical here? Okay, equipment ground conductor. So I want you to remember, the only time these flexible, you don't need an equipment ground conductor in it, only if you tie it to a fixture. Anywhere else, you must have an equipment ground conductor. The way they do it, Gary, is either to put it inside the conduit or outside. Can I put a green wire right here outside, tie it? Yep, no problem. Can I put, that would be a poor man's job. We're engineers. Where would we put it? Inside. So remember, but I don't like where the code.
Just put the flex tube out there or something to tie it to.
Yeah, length. Is there a limitation on the length that you use, that you can use it? Can I use 100 feet of this? Bring it on. 100 feet of this? Bring it on. But that non-metallic, what's the limitation on the non-metallic? 6 feet. So fixture whip, the limitation of using it. So you can't use it as a wiring method. So you just use it as tying to equipment. Okay, so you guys have all this one. Moving on. Should they all be listed? And what's the UL listing for them? UL 360 list them. 1660, these are the listing for them. Material. You can have steel or aluminum for these. Obviously, the non-metallic is going to be non-metallic. This one is steel with non-metallic cover, the material that they make them from. Can you see that? the material that they make them from. So steel or aluminum for the flexible metallic conduit, steel with a metallic cover on it, and this is non-metallic material. Rough edges, do you have to smooth the rough edges? I hope so. You know, otherwise you're going to damage the insulation for all of them. Securing, I want to go to the securing right away. Securing and when you use, can I get you guys to highlight the following? 12, 12, and 12, and 4.5, 4.5, 4.5. Okay? So you support the every 12 feet from a box and 4 feet in between with some fixture web. Can you guys see? I'm going to highlight the fixture web. Where is it here? Web, 6 feet, 6 feet. Where's the web here? Somewhere web, and 6 feet. Is that web? Web. So can I use it as a fixture web, gentlemen, to tie to equipment? And how far can I tie it to the equipment? Fixture web, yes. How far you need to support it? 6 feet. Start from the box. Here's my box. If you have a listed fitting, they use it. What they do is they have a listed fittings here, and they put it in the box here, and they take 6 feet and tie it to the first fixture. Another one from here, 6 feet, and tie to the second fixture, and they keep going. And sometimes they go from fixture to fixture with 6 feet. Cheap, very cheap. They go from the box into this fixture, 6 feet. Then from this fixture to this fixture, if it's more than 6 feet, they just support it in the ceiling. From this fixture to this fixture, to the third, to the fourth, to the fifth. And by doing it this way, they can only have one box. You don't have to have multiple boxes. Very cheap, easy. The contractor love that way. Easy installation. Fixture to fixture. Any comments, any questions guys about the support? So 6 foot fixture web, no support, otherwise 4.5. Okay, sizes. What sizes do they come? They all come from half all the way to where? From half all the way to a 4. Almost all conduits stop at 4, except a few of them, very few of them, go larger than 4. So they stop at 4, almost all of them. They have 3/8. They have a couple of applications for 3/8 guys, but for the most part, they stop at 4. In sunlight, can I use them in sunlight? No problem for these two, but this one has to be listed, or all of them have to be listed. Temperature. Now remember, there's something called temperature limitation. Does this guy have a temperature limitation? I have to, anything metallic, don't worry about temperature limitation. You put anything non-metallic, guys, you're going to wonder at what temperature it's going to melt. This will take a lot of temperature to melt this steel. PVC, yes. So this one, you have to worry about 60 degrees Celsius. That's hot, guys. Limitation of 60 degrees Celsius. You know what 60 degrees Celsius? Yeah, that's burning, man. That's 60 degrees Celsius is burning. Yeah. Okay, this is my favorite. Underground. Let's use about the underground. Can you bury these babies? Can you put them underground? First of all, this guy I'm holding, can you put it underground? I hope not. How about if you put a jacket on it? Only they make them, guys. I hate the manufacturer. They make a jacket that you can bury. Not commonly used, but why would you use it underground? I can't think of any application where you have to use a flex underground, but
You know, you kind of go like in like that.
yeah, I'm sure. Yeah. Under what? Under rocks. Yeah. Remember, guys, there's so thousands and thousands and millions of applications nationwide for these cables. So, what they make them, the non-metallic ones, if it's marked for direct burial, bring it on. What is the use for this? The use is always flexibility. The use is always flexibility. The use is always flexibility. Can I get you guys to understand the typical application of this guy is only to tie to equipment and for flexibility. Now, in wet location, can you guys highlight the word wet? Can you use this in a wet location? If you go through New York or any states that don't use 2014, they used to allow it, guys. I think they stopped in 2005, if I remember right. Maybe 2005 or 2002. They used to allow this outdoor. So there's certain states they still allow it outdoor. But I would say you say no. No outdoor for this guy. These guys, of course, the reason why they are non-metallic or have a jacket on them because they want to use them in wet location. Any question about the flexible? You guys have, we went through all chapter, almost chapter 3. I have one more thing about a couple of cables and I'm done. Can you guys hold it? And you're going to start throwing things at me. It's Friday. But you hold your horses. I promise no more than 10 minutes. So we went through the cables, guys, right? Then we went through the these called them non-flexible conduits, non-flexible. You can see. These called flexible conduits. There are 3 types of these. We went through 4 types of these, right? And we went through 3 types of the cables. Now we're going to do a special 3 types of a special cable, guys. And then we will let you stop listening to Chad. All right. The last cable I'm going to go over, guys, here you go, is SE cable. Can you guys go, please, to SE cable? What the heck is that, boy? What does it do for a living? Now, I think Jerry can tell us a little bit about that, guy. That's your jurisdiction when you were the... So SE cable, it's called service entrance cable, guys. It's listed as service entrance cable. It looks like this. Looks like this cable. Service entrance cable. Now, this is SE cable, service entrance cable, SE cable. Now, look at the insulation that they come from. It's flame retardant, moisture resistant, up to 600 volt. Internal radius, not to exceed. You guys remember that 5 times the radius? Ampacity, you have to look at the table 310.15b16. So that's typically they use them. This is typically guys used to bring the power to the building. And if you look on the farm on different buildings, to take a power from one building to another building overhead. You guys overhead, from building to building overhead. So that's basically the application for that kiddo. Okay, let's look at this is your SE2 continue. We talked about insulation, guys. You have RHH. Uses permitted bare uninsulated conductor. Now, can I use it to wire inside the house? Yes, you can use it to wire inside the house. You treat it like Romex. SE. Now, SER, another cable that they have, guys, is SER. Same as above, the same application. So also service entrance conductor, same application. You can see that SE or SER, guys, typical for bringing the typical application for them, bringing power to the building overhead and taking power from one building to another overhead. Am I making sense? Okay, so these are the typical application for them. And I swear I had one here, but I know Jay stole it, so I'm not going to search for it. Okay. SEU. What does the U stand? Service entrance underground. So can anybody guess what would you use it for? Yes. Underground burial, yeah. Yeah. Here you see the typical application for it, guys. Typical application for this guy, bringing the power to the building, no conduit, direct burial, or really taking the power from this building that we own and operate to another building across the street that we also own and operate. Does that make sense? From building to building. That's where the U is. The U is, guys, for underground. So, can you use above ground? Yes. Here's the installation that comes with it. 90-degree, same as blah, blah, blah. Here's all the application. How about the USE? Same thing, exactly like the same thing as application is underground, bringing the power in and into the building and out of the building, into the building and out of the building. Okay. Covering, insulation, uses permitted. All these guys are almost all of them. I'm going to move into that one. So that's, we talked about the USR and US. Okay. So the last thing I'm going to say, guys, is I don't want to spend too much into these cables. Remember the USR, all these things are service entrance conductor. You can use them to bring power to the building, from the building to another building. Can I use them as feeders? Yes. Can I use them as services? Yes. Can I use them as branch circuits? Yes. Can I use them inside the building? Yes. You'll be fooled. They're expensive wiring inside the building. You know, you wouldn't use them. Why would you use a USE inside the building when it's they're a cheaper application? Like if you're doing dwelling and amp, if you're doing commercial MC. So, any comments, any questions about these guys? That's basically the whole wiring methods. The last thing I'm going to show you guys is I'm just going to go to one article, quick, promise here, and show you how, and they're all the same, guys. Okay, here you go. So I'm going to go to chapter 3, expand chapter 3. Can you guys see where it says, I'm going to go to MC cable. Can you guys see? I'm going to go to and pick one article, MC cable 330. Could you please go to 330 MC cable? Thank you, thank you, thank you. In a few seconds, you guys are going to start throwing things at me here. Electrical code book, yes, please. So when you go to the electrical code book, and I don't have time, guys, to walk you through all of them. They're all the same. All the information that I showed you are coming from where, John? They're all coming from the NDC code book, chapter 3. Do you guys see the article that talk about, look at this, the article that talk about MC cable is article 330. The first section is general, scope, it covers this, definition, what is in under definition, 330.2, guys, it will give you, give you the scope, what does it do for living, and the other one give you the definition, factory assembly of one or more insulated conductor and what's not. Then you go under installation. Can you guys where it says installation? Every time you see .10, so Alex, any article that has .10 in it in the wiring methods is always uses permitted. So if I ask you medium voltage, where would you find in the medium voltage, where can you use a medium voltage cable? You're going to go find the article that talks about medium voltage. It's in chapter 3. Then go to the section that has star, which is the article .10. Read underneath it. It'll tell you where you can use it. See how easy that is?
So
can you guys see that? That section here, they're all the same. So whenever you use .10, what does that mean? This is where they list where you can use this wiring method. Standard for all wiring methods.
So .1 is definition, .10 is uses permitted.
.2 is definition actually.
.2?
Yeah, .1 is the scope. I know. I think we said it. See, .1 is scope. .2 definition. Okay. Now moving. Here's what you can use. I'm not going to read through it, guys, but you can see it. Uses permitted for service, feeders, and branch circuits, for lights, blah blah blah, all the way down to in a cable tray. And the last thing is .12. Can you guys see .12? What does .12 mean? Uses not permitted, where you cannot use this cable. So I know, Tony, you know that. Gary, if you want to know where you can use a cable, any cable, where would you go? To .10, .12. If I tell you, is this cable approved for hazardous location? Well, I don't know, Chad. Let me go check on it. So you go check on the .12. Okay, so let's go. How about, is the MC cable approved for physical damage, subject to physical damage? Is it? No. How do you know it's not? It says it here. Okay. So these are the few things. .17, guys, rough or through in axis Eric bends. Every time you see .24, where did it go? Smooth bends. Every time you see .24 for any wiring methods, always tells you this is what? Bending radius. And what did we say about the bending radius? We refer you to a couple of tables for bending radius. Yeah. And in this case, they're giving you we looked at these before, right? Okay, this is my bending radius. Moving into, and I'm picking, securing and supporting. Every time you see .30, and I don't expect you guys to memorize this, but be aware that the people who wrote the code book, Gary, they made it really easier for all of us to use, especially in the wiring methods. You know, the wiring methods are really easy. .30, securing and supporting. Wherever you see an article, medium voltage, .30, it'll tell you how far you secure it and support it. And we talked about securing and supporting it, guys. At 12 inches and not securing and supporting. Okay. Moving on, can you guys see unsupported sections and what's not? Single conductor, boxes, ampacity. This is my favorite. The ampacity of the cable. How much current this conductor can carry? Which column are you going to go to? It will tell you guys .80. Every time you saw .80, that will give you the ampacity of that cable. It will refer you to these two too, right? It refers you to these 310.15, basically 310.15, guys. and and um, and 310.60 because there's medium voltage here. The last thing is about construction. Can you guys see how they construct it? How many conductors? What's the maximum size is? Does it have an equipment ground conductor 108? Insulation, over 1,000. Remember, there's an over 1,000. I told you guys it is over 1,000 insulation. So that's basically, guys, typical article that talks about wiring methods. And Gary, I'm going to talk to you 10 years from now when you become a big guy and managing your own project, and you sit and you laugh at all these articles, how easy they are. 10 years from now. Huh?
Will that make lots of money?
You will.
Average.
Guarantee you. Now, Jay, I told when it used to get complicated, guys, and get people frustrated, I said, well, guys, you have two options. You guys sit in the bar, drink, and do something, and go work at McDonald's, flip hamburgers. A lot of people do that.
You hear about them?
Or,
You hear about them?
yeah,
Minneapolis?
marching.
They want $15 an hour.
Yeah, I think they should have. Then you will be making 35. Remember, scale goes up for everyone. Because how would if somebody flipping hamburger for $15, they can't pay an intern $12 anymore because he can go flip hamburgers for
Yeah,
more.
but now you just raise the price on housing, apartments.
Yeah, then you start buying a hamburger for $20. Okay.